SAT now allows the use of Desmos to solve some of its problems. For example, those involving straight lines, parabolas, and other kind of graphs, and maybe some circle or something like that. So let's take a look at a quick demo of how the Desmos is used and how you can use it to solve the problems in your SAT exam. So let's start with, I'm going on my laptop, but whatever functions I will do, you can watch in this screen. So to start with, let's start with this equation y equal to a simple x plus, let's say, 5. This is a simple straight line equation with a gradient of 45 degrees and y-intercept of 5. Now you note that you don't actually need to write y. It is implicitly, if you just write x plus y, then it's assumed that the equation is y equal to x plus 5. And this is important because you want to save time in typing those things. Now let's go ahead and try to find out the intersection of these lines, and I will straight write y equal to x plus y to make sure that you understand this lingo. And let's say I want to find its intersection with another line, 2x plus 7. So this is the thing. You can find that these lines are intersecting at point minus 2 3. So if you are given two straight lines, you can find their intersection using these calculations. Let's say now we have another set of two lines in which we are given to, let's say one line is 2x plus 5, another one is 5x minus 7. That's how it looks like in something like that. And I want to find out the reason represented by a straight line. So this one will go all the region that y is less than 2x plus y, and I want to find out another region y is greater than or equal to x minus 7, let's say 7. So this is the region that is represented by the second line. Okay, so then you can find that the common region is here. For example, a question could come up: does this which of the following points lie in the region contained by these two straight lines? Let's move on and find out the equations represented by a parabola. For example, y is equal to x squared plus 2x plus 3, something like this. Remember, you need to type it using that letter on the top of this letter 6 on your keyboard. So this is how the parabola looks like, and you can plot it. And if you want to find its intersection with, let's say, line y equal to 3x plus 5, you can find it this way, whether it's intersecting or not intersecting. Maybe x plus 5, or let's say make it x plus 12. This is how it looks like. The line is intersecting at these 2 points. So you can find this the intersection point. There are a few other features in the Desmos that you need to be aware of. You can draw a table, for example, a list of the point 2 and 4, and then maybe 7 and 14, let's say like this. And then you can click on this point and you can draw a line of equation of the straight line that's passing through these points. There could be more line, maybe like 12 and 20 it looks like, and then there are few features into it. Just click login, and then it can show you the best fit of this line called linear regression. You can do that. Okay, other things you probably don't need to. So these are some of the features of the Desmos that you can use in your SAT exam. Make sure you understand the graph. It's very good. SAT wants you to be able to understand it. What I'm going to do now is I've asked ChatGPT to give me a set of SAT questions that I can use to solve using Desmos. So let's say this equation is a system of equation 2x minus 3 and x square. What is the sum of all the x coordinates of the solution? So there could be a, so let's try to just plot these two equations and see how it looks like. And so what I do is x square minus 5, I write it here, x square minus 5, this is here. And then I look at all the solution. So this solution is, let's say, minus zero point 0.7, and this is 2.2. So or something here, 2.7 minus zero point 0.7 to around 2, that should be my answer. What is the sum of x, all x coordinates of the solution? 2x minus 3, x square minus 5. Sum of the x coordinate solution, minus zero point 0.7 and 2.7. So 2.7 and should be around point. So I'm not sure about this one, but let's move to the next one. This graph of this function has exactly one intercept. What is the value of k? So x square minus 6x. What I would do is I'll plot the graph with different values of has of k, and then see which one has only one intercept. I will start with x square minus 6x. uh, x square uh, x square minus 6x, and then instead of k I'm going to see how does the 5 look like here. If I write 5, it has two solutions. So I go back and write 9 in place of it. I see that 9 has only one solution. The correct solution is B. Now you can also use Desmos to plot the or to find out the value of the something like that. So what I would do is I'll write this equation, and instead of t, which is the number of hours, I'll substitute 3, 4, 5, and 6. So I'll do it 500 into 1.2 and then to the power of, and then let's see, we are asked 3, 4, 5, and 6. If I write 3, I get 864, and then 4 I get 1036, and for 5 I get 1244. That looks like to the right answer. So when it's 5, its value is 1244. So approximately after 5 hours this population will exceed 1200. uh, and then which of the following points satisfy this system of equation? So just plot these two, y equal to x squared, uh, y equal to x squared, and the second line I'm going to plot is y 4x minus 3. This is 4x minus 3. Y is less than 4x minus 3. 4x minus 3 greater than or equal to x squared, and less than or equal to 4x minus 3. So if I carefully look at, maybe somewhere around 2 and something, uh, 2 3 is probably looking like the right solution. So if I go 2 and maybe 3, it's maybe slightly out. 2 3 is here, so it may not be inside it. Now let's look at what other points are there. 3 3 5 may be the right solution. 3, so 3 here is here, and maybe 5 maybe not. And then we have 4 6. Let's take a look at this. 4 6 is also outside. So how about the first one? 1 and 2, 1 2. So 1 is here and 2 is here, so this is well within it. So A is should be the answer. Absolute value intersection, how many solutions does this equation has? So let's plot these two graphs, x square minus 4. So this graph is x square minus 4, and then this equation is nothing but mod of x minus 2 is mod of x minus 2. So this is the second equation I plot. Okay, and so you need to be careful about this one, x minus 2, this x minus 2. So what are the solutions of these two sets of equations? We can, how many solutions these two have? I can say that one solution is looks like minus 3 5, another solution is 2 0. It has two solutions. And then linear regression, this linear regression is it shows a table, shows the relationship between x and y. So what I do is I go ahead and click this plus button and add a table and add all the data 1 3 2 5. So 1 3 and 2 5, and then I also add 3 7 and 4 8. 3 3 7 and then 4 8. And then what I do is I click over here and then I plot a line. So this is how the line looks like, and I can add regression. So this is how the line actually looks like. It intercepts at the y-axis at about 1.5. So maybe around 1.5. So which equation best fits? So I think 1.2 is closest to what we have, and it has a slope of about 1.8 or 2. For example, if I do this is rise over, this is about the same as this is what the equations show, that 1.7x plus 1.5, which is closest to this was one. Other ones are quite far away. Now move on to this one. Which is larger, or which value of x does this is equal to this? So all of them are just plot these two curves, and let's, this is x squared and plus 2x plus 1, and then 3x plus 7, 3x plus 7. So these two are the two curves. Now for which value of x does this is equal? So what are those two values? Well, looks like one is at minus 2.3 and another is at 316. So 3 should be the right answer. There's another answer, but now this should be a simpler one. I mean, there are ways to solve this to find the minimum value, but this is going to be a quick way to solve this equation. X squared minus 6x. Now the minimum value happens at, let's say, x equal to 4. X squared minus 8x plus 15, x squared minus 8x plus 15. So 4 minus 1, 4 minus 1. So minus 1 is the minimum value, and it happens at x equal to 1. So as you can see, it's possible to solve all this equation, many of them very efficiently in Desmos. So you should practice this. Even if you don't use Desmos, do practice graphing by using pencil and paper, by using Desmos. But visualization is one thing you will remember, and it's easy to reproduce in the exam. And thanks for watching.